Our next video is about common segments and segment addition. So we're going to start by looking at this little example of these snails. And we have Fred and Hernan going for a walk. If you notice, these two pieces are the same length. So these two pieces are congruent. So they both walked the same distance. They were just coming from an opposite direction. Because they walk the same distance, they share this piece in the middle. So both of them have this piece in common. So this common segment theorem is saying that because the whole piece, ST, his whole piece, and his whole piece, since they're congruent and they both share this piece in the middle, then the outsides have to also be equal to each other. And this is another way that it's kind of written. So if segment AC, that's what you're going to write on your notes. So if AC, what's going on with my pen? AC is congruent to BD. So that's this piece is congruent to this piece. Then AB is congruent to CD. So if the two longest pieces are congruent, they're sharing this piece in the middle. So obviously that piece is congruent to each other. And the two little outside pieces left over are congruent. So if AC is congruent to BD, then AB is congruent to CD. So that's our theorem. This is our first theorem. Remember that postulates are statements that we accept as true. So that was things like, if I have 2 points, then I can make a line. A theorem is a statement that you can prove using logical steps. So the steps are deductive reasoning, which we will work a lot this year on proving things to be true. So we're going to try and prove this. We know that ST is congruent to YR because it says so. They said in the beginning that if ST equals YR. So we know that's true because they told us that it was true. And this they people is just they, the world. So right here, because they told us, we know that it's true. Okay? So we also know that ST equals SY plus YT. So that says that this whole segment is SY plus YT. They just broke down the two little pieces. This piece and this piece equal the whole thing. Okay. The same thing for the second half. The whole thing YR equals the big piece and the little piece. I broke it. So then if we substitute, we can say, so we're substituting this right here for this part. And then we're substituting this part for this part. So ST is the two pieces, and then YR is these two pieces. Then, since they have this part in common, we can cross it out. So all we're left is this piece on the outside equals this piece on the outside. So that's how we prove things. We take these logical statements of things that we know, and it gives us a final statement. So for an example, this one is not on your paper, it's just an example. ST equals YR, so that this piece equals this piece, and YR is 14. So this whole thing here is 14, and it tells me that TR is 4. So this little part is 4. So then I know that if this is 14 and this is 4, then this has to be 10. The piece in the middle has to be 10. So now that equals 14. And I know that this part that's 14, the YR that's 14, that means that ST has to be 14. So this big part has to be 14, and if so this big part has to be 14. So if this part is 10, then all that's left is this part, which has to be 4 also. So this is 4, and this is 4. So SY is 4, and they're equal. So this one is on your paper, so we're going to work this one out. Of all the information that we know and have. So let's see. RT equals SW. So that's this. RT equals this. So because we know that, we know based on our theorem that the two outside pieces of that have to be equal. So this equals this. So those are congruency marks. As long as they have the same number of marks, that means they're equal. TW is 7.3. So if that's 7.3, that means RS is 7.3. SW is 12.8. So this whole part is 12.8. If we know that that's 12.8, if we subtract 12.8 minus 7.3, that would give us SC, which is 5.5. 5.5. We did this one, and this one, and this one, and then WY equals 4RS. That means 7.3 times 4, which equals, I thought it was down here. That's what I was looking for. So that equals 29.2. 29.2. So now I know all of my little pieces. I'll go ahead and highlight those for you. 7.3, 5.5, 7.3, and 29.2. So then as we go to the bottom and just fill in the pieces, then we just find what they're looking for. So RS is 7.3, ST was 5.5. EW was 7.3. And then all the other ones, they're adding more than one thing together. So RT would be the 7.3 plus the 5.5, or the 12.8. And RW goes from R to W. So you add all three of those together and get 20.1. RY is the whole thing all together, which is 49.3. SW was actually one of our given things up here, which is 12.8. SY is just the whole line minus the R, but SY is 42. And then TY is from here to the end, which is 36.5. All I did was add those numbers up. I just didn't want to waste time adding them up. So you're going to try on this one, determine the length of each segment. I'm going to kind of go through these steps with you so you know what all those things are. So C is the midpoint of BE. So that means that BC is congruent to BE. So that's this part is congruent to this part. AD is 23. This is 23. And then DE is 4. So this is 4. DE is not on the bottom. So that one's 4. And then we did this one. AD is 23. So that's from here all the way to here is 23. Which means the whole thing would be the 23 plus the 4, or 27. And then D is the midpoint of CE. So those two little parts are congruent. So I want you to take this information and fill in the rest of it. And this is what we'll talk about starting when you get back. Don't forget to do your feedback.